Hey guys, this video is a intro to triangles, so it's going to summarize some of the things you watched in the last video, but also extend your knowledge of angles in a triangle and especially types of triangles such as isosceles. Okay, I got a couple of warm-up questions for you. You can go ahead and pause the video and work these out. This should be easy if you watched the last video about classifying triangles. When you classify triangles by their sides, you're looking to see if they have no congruent sides, they would be scalene, two congruent sides, isosceles, or if all three sides are congruent, equilateral. To classify triangles by their angles, you're looking to see if there are any right angles. If there's a right angle, that would be right. If there's an angle that's bigger than 90, that would be obtuse. And if all three angles are acute, we would classify that triangle as acute. So question A, since all three angles are different, this would be scalene. And there's a 100-degree angle, so this would be obtuse. Now on a quiz or test, if it asked you to classify by its sides and angles, you would need both of those words in order to receive full credit. Part B, I noticed that there's a right angle, so I could say that that triangle is right. And also I noticed that two of the sides are congruent, so this would be isosceles right. If this doesn't look familiar to you, then you may want to pause this video or exit now and re-watch the last video because that's where I got this information from. Also, another review, a little warm-up for you. Make sure you retain what you just watched in the last video. Go ahead and find the value of x, and then find the measure of each of the given angles. So these two equations I've set up down below allow me to solve for x because of the triangle sum theorem. So I'm adding up all my three angles in each triangle to equal 180, and then I just do out my algebra. So once I know my value for x, I can then plug it into each of my given angles and solve for their actual measures. And a good check method is to add up those angle measures, and they should total to be 180. So 60 plus 30 plus 90 does add to be 180. And this example should work out the same as well. So if x is 12, I then want to take 12, plug that in to my expressions for a and c, and then figure out their measures. So this should be 43 degrees, right? And then 47 degrees. Then again, I should be able to check 90 plus 43 plus 47 should be 180 degrees, and it is. So just to summarize, the theorem that you needed in order to solve these two problems was triangle sum theorem. And if you don't quite remember that, or you didn't watch the previous video, I'd go back and just review what that is so that you can be successful in this unit. Another theorem involving triangles is the exterior angle theorem. And the exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So that's kind of a mouthful. So to give you a good example, I'm going to start off with just one that has just angle measures, no variables. So go ahead and copy down this diagram. First of all, the exterior angle is on the outside of the triangle, and it's formed by one side of the triangle, and then if you extended another triangle past that vertex, that green angle is going to be the exterior angle. Now, let's pretend we don't even know anything about the exterior angle theorem. I'm going to use my triangle sum theorem. So if this is 60 and this is 80, I can figure out what this angle has to be. Since all three have to add up to be 180, this angle would need to be 40 degrees, right? Now I have a linear pair. I have this 40-degree angle and my exterior angle make a linear pair. So we know that linear pairs also add up to be 180 degrees because they're supplementary. So if this is 40, my exterior angle must be 140 degrees. Okay? Now, back to the exterior angle theorem. I figured out 140 degrees by using triangle sum and linear pair. Every single time you do this process, you should notice a pattern. And the pattern is that if I added these two angles together, I would have gotten 140 degrees anyways. And that's basically what this theorem explains. Instead of doing two steps, I can just add the two interior angles that are not next to my exterior angle, and that sum, or that total, will always be my exterior angle. Okay, so all you have to do on a quiz or a test with a question like this is just to add these two angles together. 60 degrees plus 80 degrees equals 140 degrees. That's my exterior angle. Oops. Now, sometimes you're going to have examples with variables. And in order to solve these problems, you have to know the exterior angle theorem because we can't use triangle sum in all cases if we don't know the actual measures of all the interior angles. So in order to find y, I'm going to set up an equation using the exterior angle theorem, which states that my exterior angle, that would be 2y. This angle here is my exterior angle. So I have 2y is equal to the sum, which means add, of the two non-adjacent interior angles. That's these two angles that are not directly next to the 2y. So that would be the 50 and the 90. So I add those two together, 140. So y must have a value of 70. Now I'm not going to put the degree symbol because y doesn't represent an angle, it just represents a value. But if I were to plug that value back in for y, I should be able to check that it is equal to the sum and that it is a linear pair with this, and then etc. Okay? Example 3, we need to find x. So this one I really cannot use my triangle sum because I don't know the measure of this angle, I just know that its value is 2x. So same thing, identify your exterior angle and set it equal to the sum of the two non-interior angles. Sorry, the two non-adjacent interior angles. So find my exterior angle. Two non-adjacent interior angles. So 30 plus 2x. Now we can proceed to solve for x. So just like you normally would, x should equal 30. So if I plug this back in, it should check out. Go ahead and jot down examples 4 and 5. I would like you to write out the actual word problem for example 5 because word problems like this could pop up on a quiz or a test and it's a good thing to have in your notes. When you're done working through the problem to the best of your ability, then click play and see how well you did, or ask a question if you're not quite sure. For example 4, I set up my equation by stating that the exterior angle will be equal to the sum of the two interior angles that are not next to the exterior angle. And then I just combine my like terms, simplified, and solve for x. For example 5, I would recommend that you draw a picture first. So this is what I've gathered so far. I have a triangle ABC, I know angle A, and I know that angle B is 8 less than twice the measure of angle A. So that means if I double the measure of angle A and subtract 8, then I can find the measure of angle B. So if I double 42, that would give me 84. Subtract 8 from that, so that would give me 76 degrees. Okay, so angle B is 76, angle A is 42, and I need to find the measure of the exterior angle at vertex C. So I've marked that with an X. Okay, so once you work out your problem and you draw yourself a little picture, this problem is actually very easy, because now we're just going to say my exterior angle is equal to 42 plus 76, add them together to get 128 degrees. No, 118 degrees. Thanks to those of you who caught that, and we're going to fix it anyways. Isosceles triangles, we know from the previous video, isosceles triangles have two congruent sides and two congruent angles. So here's an example where I'm given two congruent sides, and then example B, we would be given two congruent sides again. So let's jump into A. So to find the value of X, I noticed that both of my sides have tick marks, which means that they must be congruent. So right away I'm going to set these equal to one another and then solve for X. Whoops. Okay, so I got my value for X. Now, in order to find Y, I need to know something special about isosceles triangles. And that is that whenever I have my two congruent sides, the angles opposite of those sides are always congruent. So if this is 55, that means that this one's 55 degrees. So now back to the triangle sum. So if I have two angles that are marked, 55 plus 55 plus Y, all three of those must equal 180 degrees. And then I can simplify, solve for Y. So 110 plus Y equals 180. Y must be 70. Whoops, got cut off. Y must be equal to 70 degrees. And you can always check it by plugging it back in and actually making sure that all three do add to 180. So part B is very similar, although we do have a special case. So I can solve this problem even though I'm only given one angle measure, because again I know that this is an isosceles triangle, so I know these two angles must be congruent. Now it would not really be helpful to say X equals Y, because I don't know what either of them are. However, I do know that this is 90. So if I take away 90 from my sum, that leaves 90 degrees left over. And if X and Y are congruent, I'm going to put my little arc marks, right? Remember those? Arc marks to show that those are congruent. So if there's 90 degrees left over and they need to be equally shared between X and Y, that means they each must be 45 degrees. So X equals 45, Y equals 45. So just to summarize what those two problems were showing us is that if we have congruent sides, then the angles opposite of those congruent sides will also be congruent. And I would mark those in your notes with either like a different color, or the arc marks are always a good idea too. Here's two examples where the given information is that two angles are congruent. Pause the video, see if you can set up an equation. Think about the relationship between those sides. So if we are given that two angles are congruent, we know that these triangles must be isosceles, which means that we know something about their sides. So here's how I would set up my first step to each of these equations. So because of these congruent angles, I know that these sides are going to be the same as well, because if we have two congruent angles, this triangle must be isosceles, right? Same thing with this example. These arc marks are a huge clue that the sides across from them are going to be congruent as well. So I can set them equal to each other. So now if I go through and combine my like terms, I can find my value for x. Again, you can always check it by plugging that value back in and confirming that the opposite sides are actually congruent to one another. So summary for these two examples would be that opposite sides of congruent angles are also congruent. So if you're given this, then you know that these two sides would be congruent. All of that has to do with isosceles triangles. Anytime an isosceles triangle comes along, you know all of these properties. Equilateral triangles, we know all three sides are congruent and all three angles are congruent. But one thing to add that you probably don't already have in your notes is that if all three angles are congruent, that means they all must equal 60 degrees. So there's a few ways that equilateral triangles can be represented. And here's the most common one that you'll see. If all three sides are congruent, then you also know all three angles are congruent. If all three angles are marked with an arc, you know all three sides are congruent. And this one's interesting because if you know that one angle is 60 degrees and the other two are the same, these by default, because of triangle sum theorem, have to also be 60 degrees. And so therefore, all three angles would be congruent and all three sides would be congruent. So that's another example of an equilateral triangle that you may see. If you would, go ahead and flip to your list of reasons because we have a bunch more to add. So I believe we left off right around here. So if you haven't already, go ahead and put the definition of perpendicular on your list of reasons. We've been using that a little while for the last couple of weeks. And then all of the following reasons we talked about today in this video. Okay, so this summarizes the intro to triangles. When you come back to class, we'll be doing a bunch of problems that are harder than the ones in this video. And also we're going to be using these reasons in 2-column proofs. So it's super important that you have your list of reasons updated. Have a great day, guys. I'll see you soon.